This is the homework video guide for applications of prime factors, and for the very first question, question 1a, I need to state the greatest common factor for 14 and 21. So this basically means what's the biggest number that divides into 14 and 21. And just by inspection, I know the answer is going to be 7, but a method that we're going to be using in this particular video guide is the ladder method here. In the previous video, sometimes this is called the division table method. So what I'm going to do here is I'm going to put 14 and 21 on the side here, and I'm going to think of a number that divides both 14 and 21, and the number that comes to my mind is 7. So 14 divided by 7 is going to be 2, and 21 divided by 7 is going to be 3. And this is where I'm going to stop here, because when I look at my numbers 2 and 3, these are prime numbers. I can't think of another number that divides 2 and 3 at the same time. So the GCF can be found right here, which is 7. And once again, that makes sense because 7 is the biggest number that divides into 14 and 21. So one way you can just kind of finalize your answer is you can write GCF. The GCF of 14 and 21 equals to 7. Okay, let's move on to the next question here. 30 and 40. What is the GCF for 30 and 40? 30 and 40. So I'm going to start off by writing 30 and 40 on the side like that, and then I'll create this sideways L, this ladder method or this division table method here, and I want to think of a number that divides into 30 and 40. All right, so you can start with any number, but I like to start off with the smallest number possible, which is going to be 2. And once again, you don't need to start off with 2, but I'll just use 2 for the sake of this homework video guide here. And then now we can start dividing the numbers here. So 30 divided by 2 is 15. 40 divided by 2 is 20. And then I will draw another ladder here. And now I need to think of a number that divides into 15 and 20. And a number that divides into both 15 and 20 is going to be the number 5. And if I start dividing here, I get a 3. 15 divided by 5 is 3, and 20 divided by 5 is going to be 4. And this is where I stop because I can't think of a number that divides both 3 and 4 at the same time. And my GCF is right here on the side, 2 and 5. So the way we write our answer is 2 times 5, which equals to 10. All right, so the GCF of 30 and 40 is simply going to be a 2 times 5, which is going to be 10. And that makes sense. 10 is the biggest number that divides into 30 and 40. And once again, we could probably have figured that out by some inspection, but I just want to introduce this ladder method because I'll be using this method throughout this homework video guide. For question 1c, I need to find the GCF for 12, 30, and 54. So let's start off by writing the numbers 12, 30, and 54. And then I'll create this sideways L. So sometimes I call this the ladder method, but it's really another term that's called the division table method here. Now a number that divides into 12, 30, and 54 at the same time, I'm thinking of the number 2 because they're all even numbers. And now let's go ahead and start dividing the numbers here. So 12 divided by 2 is going to be 6. 30 divided by 2 is going to be 15. And 54 divided by 2 is going to be 27. Okay, and then I draw another ladder over here, and now you got to think of a number that divides 16, 15, and 27. So I'm going to use the number 3. So 6 divided by 3 is 2, 15 divided by 3 is 5, and 27 divided by 3 is 9. And this is where I can stop because I can't think of a number that breaks down 2, 5, and 9 at the same time. So in order to find my GCF, the GCF of 12, 30, and 54, based on this method here, the answer is on the side here, this 2 and the 3. So 2 times 3 is going to be 6. So 6 is the biggest number that divides 12, 30, and 54. Okay, let's keep on going here. So question number 2, use prime factorization to determine the GCF of 150 and 420. So this is basically the exact same question from question 1. We're just having bigger numbers here. And we can use our little ladder method here. All right, so since these are both even numbers, let's think of a number divides into 150 and 420. So I will start with the smallest even number, which is 2. So 150 divided by 2 is going to be 75. 420 divided by 2 is going to be 210. Then another ladder method here. Okay, and since there's a 5 here, a number that divides both 75 and 210 will be 5. So 75 divided by 5 is going to be 15. 210 divided by 5 is going to be 42. And then I can draw another little ladder here. And now we got to think of a number that divides both 15 and 42. So I'm thinking of the number 3. So 15 divided by 3 is going to be, it's going to be 5. And 42 divided by 3 is going to be 14. And this is where I can stop because I can't think of a number that divides both 15 and 14. So our GCF of 150 and 420 is basically going to be these numbers multiplied, 2 times 5 times 3. 2 times 5 is 10, and 10 times 3 is going to be 30. So 30 is the GCF there. Okay, so what that means is 30 is the biggest number that divides both 150 and 420. Okay, for question 3b, once again, we have to use prime factorization to determine the GCF of 180 and 504. So let's go ahead and just draw this little ladder here. Since we have an even number here for 180 and 504, let's just start off by dividing this by 2. So 180 divided by 2 is going to be 90. 504 divided by 2 is going to be 252. All right, so I will continue with this ladder method because I still have even numbers here. So let's go ahead and divide by 2 again. So 90 divided by 2 is going to be 45. And 252 divided by 2 is going to be 126. Okay, so now I can see that there's a 5 here, so this is definitely not an even number. So let's see, let's try the number 3 now. So 3 definitely divides into 45 and 126. So now we have 15. 45 divided by 3 is 15. And 126 divided by 3 is going to be 42. And then we just continue on with the ladder method here. A number that divides into 15 and 42 is going to be 3. Okay, so 15 divided by 3 is going to be 5, and 42 divided by 3 is going to be 14. And this is where we can stop because there's no number that divides both 15 and 14. Okay, in order to find my GCF now, the GCF, the greatest common factor of 180 and 504, is simply going to be all these red numbers being multiplied together. So 2 times 2 is 4, 4 times 3 is going to be 12, and 12 times 3 is going to be 36. So 36. And there's my final answer for that particular problem. Okay, let's keep on going. For letter F, another GCF question here. So let's see if we can just maybe continue on by writing out this table here. And this sideways L. Okay, so now I have a 5 here and a 0. So let's start this off by dividing both numbers by 5. And if I do that, 525 divided by 5 is 105. And 850 divided by 5 is going to be 170. And then I can continue drawing a ladder here. And I have multiples of 5 again. So let's divide everything by 5 again. And this time I'll get 21 and 34. So 105 divided by 5 is 21, and 170 divided by 5 is 34. And this is where I can stop because there's no number that divides both 21 and 54. So my GCF in this case, my GCF of 525 and 850 is going to be 5 times 5, which is 25. Okay, and that's it for 3F. Let's keep on going on here. All right, question number 5, I need to find the lowest common multiple for 4 and 6. Okay, so what I'll do here is, this is a new question now. We've got to find the lowest common multiple here. So let me show you how you can apply the ladder method to this particular problem here. Just by inspection, I think the lowest common multiple is probably going to be 24 here. No, actually 12 here. And let's just see how we can show our work for this particular question. So I will start off by writing a 2 here because 2 is the smallest even number. And now 4 divided by 2 is going to be 2. And 6 divided by 2 is going to be 3. Okay, and this is where I'm going to stop because I have all prime numbers there. And if you want to find your LCM, your least common multiple of 4 and 6, this time when we find the lowest common multiple, you just take all the outside numbers like 2, 2, and 3. So if you multiply 2 times 2 times 3, you will get 12. So the least common multiple is 12. Once again, you're just multiplying those 3 numbers together to get 12. Okay, before I move on to the next question here, let's just take a look at this lowest common multiple and what that really means. This one takes a little bit longer to produce, but I just kind of create this table here. So if your numbers are 4 and 6, if you want to find the least common multiple between 4 and 6, you want to find a common multiple, right? So common multiple here, if you went ahead and wrote and write out the multiples of 4, you have 4, 8, 12, 16, 20, 24, and a bunch more. And for 6, the multiples of 6 are 6, 12, 18, and 24. As you can see, the very first common multiple that comes up is 12. Right? So you can definitely write out all the multiples for both 4 and 6 and find the very first multiple that comes up in that list. And when you have small numbers like 4 and 6, it's not too hard to produce a list. Basically, I hope this little table here shows you what the answer means. 12. 12 is the first common multiple between 4 and 6. And another quick way to kind of get 12 is by using this little ladder method here, which I'll be using now throughout this homework video guide. Okay, let's keep on going along. Question 6a now. Use prime factorization to determine the least common multiple of 14 and 30. Okay, so now I have my 14, I have my 30. Let's go ahead and just draw a little table here. We have even numbers. Let's just use 2 here. 14 divided by 2 is going to be 7. And 30 divided by 2 is going to be 15. Okay, and this is where I'm going to stop because there's no number that divides both 7 and 15 at the same time. And your least common multiple is pretty much these numbers being multiplied. So the least common multiple of 14 and 30 is equal to 2 times 7 times 15, and that equals to 210. Okay, and once again, if I had to kind of create a list of the multiples of 14 and 30, so the multiples of 14 are 14, 28, 42, 56, and then we keep on writing them out. Eventually we get to 210. So the multiples of 30 are 30, 60, 90, 120, and the very first multiple that comes up that's common in both of the lists is 210. Okay, so it takes a little bit of time to kind of generate the list for 14 and 30, but this ladder method is actually a very quick way to find the least common multiple. Okay, let's keep on moving along. I have 10 and 15 now, so here's 10 and here's 115, sorry. And let's go ahead and apply the little ladder method here. I have a 0 and a 5, so let's go ahead and break this down by using 5 to divide both numbers. So 10 divided by 5 is going to be 2, and 115 divided by 5 is going to be 23. And this is where I can stop. And now the LCM of 10 and 115 is going to be 5 times 2 times 23, and this gives us 230. So 230 is the least common multiple between 10 and 115. And once again, I have a list down here. If I went ahead and create a list of the multiples of 10, 10, 20, 30, 40, eventually I would get to 230. And the multiples of 115 are 115 and 230. So there you go. There's my least common multiple there, 230. And once again, you can find the least common multiple by writing out all the multiples and finding the common number in the list. Okay, let's move on. 18 and 36. So let's go ahead and write down 18 and 63. Sorry, not 18 and 6. 18 and 63. Let's use a table here. Definitely 2 will not work as a starting number because there's a 3 here. So let's go ahead and use the number 3 now. So 18 divided by 3 is going to be 6. And 63 divided by 3 is 21. Let's continue making the table here. A number that divides both 6 and 21, we can use 3 again. And now we get 2, and 21 divided by 3 is 7. And this is where I can stop. Okay, so the least common multiple is basically all these red numbers being multiplied. So I can write this out as the least common multiple between 18 and 63. It's going to be 3 times 3 times 2 times 7. And that's going to be 126. Okay, so the answer for 6D is 126. And once again, if I go ahead and write out the multiples for both 18 and 63, the second multiple of 63 is 126, and that matches up with the eventual multiple of 18. So 126 is also a multiple of 18 eventually. Okay, so hopefully everyone can see the multiples of 18, 18, 36, 54, 72, 90, and if we keep on going, eventually we get to 126. Okay, let's move on to question number 7 now. What happens if we have a case with 3 numbers here? So this doesn't happen very often, but let's go ahead and just write out the 3 numbers right here, 6, 10, and 42. And let's go ahead and apply the ladder method here. Let's go ahead and start off by using the number 2 here. So 6 divided by 2 is going to be 3. 10 divided by 2 is going to be 5. And 42 divided by 3 is going to be 21. Okay, there's one little method that we need to continue applying for the ladder method when we're trying to find the least common multiple. And that is, in this case, there's definitely not a single number that divides both 3, 5, and 21. But I look at the 3 and the 21, and those numbers can be broken down further. So a number that divides into 3 and 21 is the number 3. If I do that, we get a 1, and then we would get a 7 over here. And this 5 right here, 5 definitely does not divide by 3, so we can just pull down the 5 like that. And now this is where we can stop because 1, 5, and 7, those are all prime numbers, right? So in the previous line, if you have at least 2 out of the 3 numbers, if you can continue breaking them down, then you continue breaking them down. And we can now see that the least common multiple between 6, 10, and 42 is now going to be 2 times 3 times 1 times 5 times 7. Right, so if I multiply all that out, we should get 210. All right, so 210 is the least common multiple there. Okay, and once again, if you went ahead and wrote out all the multiples of 6, 10, and 42, and if you kind of examine this list, the first common number that does come up in all three of those lists there is 210. So yeah, definitely feel free to kind of write out all the multiples, and we will definitely get 210 at the very end there. Okay, last question for this homework video guide. In this word problem here, I believe this is question number 15. A new children's encyclopedia has 950 pages, and each page contains 2 background colors for illustrations. So on page 8 and every 8th page thereafter has green as one of the background colors. And then the question states that on page 18 and every 18th page thereafter, it has orange as one of the background colors. Okay, so how many pages in the book have both green and orange as a background color? Okay, so this is another application of least common multiples. So the question is pretty much stating that for every 8th page and every multiple of 8, those pages have a green color, and on every 18th page and every multiple of, I'm getting confused here. I meant to say that on the 18th page, we have orange as a color, and on every multiple of 18, we have orange. And basically, we want to find out how many pages in the book have both green and orange as background colors. If I look at the multiples of 8 here, I have 8, 16, 24. If I keep on writing out the multiples, eventually I get 72. So what that means is on page 72, we have green as one of the background colors. And then if I look at the multiples of 18, I have 18, 36, 54, and then I have 72. 72 also has green. Sorry, 72 also has orange. Okay, so this is one of our answers here. Page 72. If I look at that page there, what we're trying to say here is page 72 has both green and it also has orange. I'm not sure if I have an orange color here. Let me just double check here. Okay, orange here. Okay. So on page 72, class, we have both green and orange as background colors, and we got to find out every single page that has both green and orange for background colors. So far we found one page, which is page 72. And since this book has 950 pages, what we're going to do is we keep on writing out the multiples of 8 and 18 until we get up to page 950. And eventually on page 936, that is the last page where we have both orange and green. So if I kind of count out all these multiples, there's 936, 864, 792, 720. So we have to kind of count up all these multiples that that match in both columns there. And if we count every single one up, there's going to be 13 of them. This is page 72 is the first one, but page 144 is the second, 216 is the third, 288 is the fourth, etc. So if I actually write out all the multiples and count them all up, there's 13 matching numbers. So that one's a bit of a tough one there. So what we're going to do here is we're going to use the ladder method and try to finish this problem off here. So what we're going to do here is we're going to start off by writing 8 and 18. And we're going to use the ladder method here. And we're going to break down 8 and 18, starting with the number 2. If I do that, I get 4. And 18 divided by 2 is going to be 9. And then what I can do after that is I can continue breaking down. Actually, this might be okay here. I can use 2 times 4 times 9, and that should give, yeah, let's just stop here. So if I multiply all these numbers out, I can say that the least common multiple here is going to be 2 times 4 times 9, and that's going to give me 72. So 72 is the first common multiple between 8 and 18. And if there's 950 pages, what we're trying to say is on every multiple of 72, the numbers will have a common multiple here. So 950 divided by 72. This gives us a number very close to 13. It's a bit more than 13, but we can round down to the nearest integer there. So this is another quicker way to get 13. So there's 13 pages up until 950 pages that have both green and orange as background colors. So this is the very quick way to do it by using the ladder method here. But if you wanted to physically count out all 13 pages, you would have to create a list like I did at the start of this problem and count them all up. 72 is the very first page that has both green and orange. And then 144 is the next page that will have both green and orange, right? Page 144. Okay, so page 72 is the first, and page 144 is the second, and then you keep on manually counting up every single least common multiple there. However, this is a very nice way to kind of finish off this problem. You just need to recognize that this is a least common multiple problem. Okay, so that concludes this homework video guide.